Good afternoon, everyone. My name is Steve Thomas. I'm the director of the MMA and MMAI programs at Smith. And today, in this webinar, I'm going to give a brief lecture on recommender systems. And the point of this webinar is to give you a flavor of what some of the lectures are like in the MMA and the MMAI program. So this will give you a general flavor. It's not exactly the same because when I lecture in the programs, there's always some in-class activities, maybe some team breakouts to do a little programming, and we obviously can't do that here today, but hopefully this kind of shows you a little bit of what it's like. So why don't we just jump right in? So what is a recommender system? The definition is it's an information filtering system that seeks to predict a rating or preference a user would give to an item. It's kind of a boring definition. The one I like, it's a system that recommends items to users. A little bit obvious, but we'll see some examples. I'm sure all of you guys have used a recommender system several times today, whether you've known it or not. You can see the Google trend popularity of the term there below. It's actually been quite popular all the way back to 2004, so it's not a particularly new system, although there's been a lot of advances and it's becoming more and more relevant, as we shall see. So here are some examples of a popular recommender system. So Amazon has one. Anytime you're shopping for an item and Amazon suggests or recommends things that are similar, that's using a recommender system under the hood. YouTube has one to recommend videos. iTunes has one to recommend songs. Netflix for movies, and there's even some more there at the bottom. Basically, any online or any internet-based company has to have a recommender system these days. So why? Why do companies need a recommender system? Well, the biggest thing is there's too many options for users out there. Think about Netflix. If you're using Netflix and trying to decide what to watch, Netflix has 10,000 shows. There's no way you're going to sit there and scroll through 10,000 shows in alphabetical order or anything like that. Your dinner is definitely going to get cold before you choose. iTunes has 35 million songs. So how are you going to find new songs to listen to? Amazon. Amazon has 480 million unique products. I didn't realize this, but a staggering stat I learned the other day is that Amazon adds 500,000 new unique products every day to their catalog. So there's just simply no way you could ever find out what's available to buy without a recommender system. And YouTube's the worst. YouTube has the worst problem. 7 billion videos. There's a lot of great stuff out there, but how are you going to find it? Back at the beginning of the internet, search and browsing was good enough. So if you went to a website and this store sold 70 products, it's feasible to just sit and scroll through all 70 products one by one. But now search and browsing is just not good enough. The scale of inventory and options and items is just too big. So that's where recommender systems come in. Recommender systems provide a bunch of benefits. The first is they help users discover new items, so items that they didn't even know existed. Recommender systems can kind of pop it up and show them that it exists. It gives a personalized experience to each user. So your Netflix homepage is going to be different than my Netflix homepage because we've watched different things in the past. And the recommender system will learn as we will see later in the slides. So this is really nice. As a user, it's really, it feels good, and it's a positive experience to know that the system is adapting to your needs and your wants and showing you just what you want and nothing else. From a business point of view, recommender systems increase loyalty because if a user has a positive experience on your website, then they're going to come back. Increase profits because people are coming back, they're spending more, they're finding new things to purchase, so they're just going to keep coming back and buying new things. And likewise, it reduces churn. So for a company like Netflix, their biggest goal is to keep people from leaving. And the biggest way to do that is to keep them happy with shows that they like. So if you can show them shows If you can recommend shows that they want to watch, they're going to be happy and they're not going to leave. So 94% of top companies say that recommender systems are very important to their success. And in my opinion, recommender systems are the perfect big data machine learning system because they can do something that humans can't do well at scale. So I don't mean to say that humans can't do recommendation. They certainly can. In fact, if you go into a local mom and pop shop in your hometown and you ask the store owner for some shoes, for example, they will recommend some shoes for you. They'll ask you questions like, how much do you run? What's your stride? Do you want this? What color? What's your price range? And they'll find a great shoe for you. But humans can't do that to a million other humans all at the same time. And they can't do it for thousands or hundreds of thousands of products all at the same time. But a machine learning recommender system can. Also, recommender systems are very easy to interact with. Users are presented with options and they click the one they like. So they don't need any technical background to use these systems. Recommender systems have provided billions, possibly hundreds of billions of dollars a year in economic lift, as we'll see. And they're used by thousands of businesses. This is not some pie-in-the-sky theoretical application that might be feasible in a few years. It's something that's been used and is in place today. Another thing recommender systems are good at is what's called the long tail problem. So if you were a store or a business and you were to sort your products by their popularity, what you would find is that 20% of your products accounted for 80% of your sales. So that's that red piece of the chart there. So your most popular products are what people see and what they buy. But you still have 80% of your products in inventory that people don't know about. It's called the long tail because they're not very popular. Where a recommender system comes in is they can recommend items from this long tail, get them more exposure to more people, and increase their sales. Here's a quick success story of Amazon. So Amazon has 100 million products or more, as we said. So it's very hard for customers to discover, impossible for customers to discover what's out there. At the same time, Amazon realized that they had tremendous data. They had 20 years of purchase history for millions of customers. So they used that to build a recommender system so that people can find products that are purchased with whatever product they're looking at. And this has been really successful for Amazon. Amazon makes $35 billion a year in revenue thanks just to this recommender system. I think that's about half of their revenue comes from the recommender system. So the goals of a recommender system, the big goal is obviously to increase product sales or product usage. They also want to include click-through rates, lookers to booker rates, things like that. Also just to improve the customer experience. So an ideal recommender system would recommend items that are relevant. You want to show the user things he or she actually want or need. You want to show them new things, novel things, something that they haven't seen in the past. For example, if you were Amazon and the user is looking at Harry Potter 5, you wouldn't want to recommend to them Harry Potter 1, 2, 3, 4. It's kind of boring. You want the recommendations to be serendipitous. This kind of means unlucky, or lucky and unexpected. So for example, this actually happened to me. I recently got knee surgery and I had to go buy a balance board for my rehab. And when I was on the website, the recommender system showed me an option for a back support for a chair. And I thought this was really cool because I was just thinking the other day that my back kind of hurt after sitting in the chair all day. And so I bought it. So I kind of felt lucky that the recommender system knew my problem. Even though I had no intention of buying something that day related to a chair or my back, the recommender system gave me a recommendation and I took it. And finally, you want a diversity in your recommendations. Using the Harry Potter example again, you don't want to show all 10 versions of Harry Potter and that's it. You want to give the user a chance to diversify his or her taste. since recommender systems are so popular, there are a lot of tools and packages for implementing a recommender system. This is good news. In R, for example, Recommender Lab is the name of a very popular package. A recent one that I've seen is called Reco, which is supposed to be a lot faster and use a lot less memory. There's a lot of great ones in Python. There's some open source tools, including Amazon's own recommender system, which they recently open sourced, which they call Destiny, which is pretty amazing when you think about it. This is a $35 billion a year business for Amazon, but they've open sourced the tool. And then all the major cloud platforms like Google, Amazon, IBM, and Microsoft, they all have recommender systems that you can use. So in the MMA and MMAI programs, we would use one of these R libraries or one of these Python packages to build a recommender systems ourselves. Okay, so let's talk about how recommender systems work under the hood. Let's talk about the algorithms that they use. Turns out there's a bunch. So this chart is a little confusing at first, but this is a classification of all the kinds of recommender system algorithms there are. So there's two main categories. There's generic algorithms that don't take into account a user's past behavior, and there's personalized algorithms that do take into account. So we're going to walk through all of these bit by bit. So let's first look at generic algorithms. So generic algorithms, like I said before, they don't take into account any particular user's history. So for example, a generic algorithm might show just the most popular items. So the items that have been, if you were Netflix, these would be the movies and TV shows that have been the most popular throughout time. Or staff picks is another way to do it. This is where human employees manually create a list of their favorite items. If anyone ever went into a Blockbuster movie rental store, you might remember there was a wall on the back called staff picks. And this was just one of the teenage employees' favorite movies that week. You could do newly added. So this algorithm would just show the movies, TV shows that have been added in the last week or last month or whatever time period. You could do trending. So these are the top movies or the movies that have increased in popularity the most over the last day, month, year. You can also show seasonal items. So for example, if there's some movies that are popular around Christmas or Valentine's Day, you could show those. So all of these work very well, and it's much better than not showing any recommendations at all, and it's better than showing random recommendations. However, none of these are personalized to the end user. Every user will see the exact same recommendations. So that's why there's been a lot of great personalized algorithms that have been created. So the personalized can be kind of split into three broad groups. There's a technique called collaborative filtering, which we can break down further, and we will. And then there's content-based, and then knowledge-based. So collaborative filtering, the main idea here is to give users recommendations based on the ratings of their peers. So that's why it's called collaborative, because you think of all the users collaborating together to filter the items. So the main idea here is you find, say, me, Steve, I'm looking for movies to watch. What the algorithm will do is find people like me, based on, we've watched similar things, and then recommend to me what my peers have been watching. Content-based is a little bit different. In the content-based algorithms, they don't use the ratings of my peers. Instead, they see what I have watched in the past and what the similarity between those are. For example, if they've noticed that I always watch horror movies, then they're going to recommend to me horror movies in the future. Or if I always watch teenage dramas, they'll always recommend teenage drama. So it doesn't matter who else has been watching horror movies or teenage dramas. It only matters what I have been watching. And then knowledge-based is totally different. This is where the user wants to be very explicit about what they want to find. So an example here is if you're searching for an apartment, you want to say, I want 2 bedrooms, 2 bathrooms, I want it downtown, and I want to pay at most X dollars a month. And then the system will go find something for you. So this isn't based on past history at all. It's not based on any kind of similarity algorithm. It's more of just a database lookup. Okay, but let's talk about all of these. So collaborative filtering. Here's just a key concept is called utility matrix in collaborative filtering. So utility matrix is just a matrix of numbers where rows are users. So in this example, we have Mr. Green, Mr. Blue, Mr. Red, Mr. Purple, and so on. And then columns are the items. So again, using the Netflix example, we have different movies, Gladiator, Devil's Wear Prada, The Matrix, and so on. And the numbers in the matrix are what this user rated that movie. You know, the rating could be a number between 0 and 5, or it could be binary, like or dislike, that kind of thing. But here in this example, Mr. Green has rated The Gladiator a 4. Mr. Green rated The Devil Wears Prada a 3, and so on. You also notice that some of the entries in the matrix are empty. This is because that user just hasn't rated that item, and that's okay. It's okay from a user's point of view. You can't expect all users to rate all items. However, from an algorithm point of view, it can be a little bit tricky. So the algorithm is going to have to take this into account. So this is called the utility matrix. And so what collaborative filtering does is it's based solely on this utility matrix. So there's 2 flavors of collaborative filtering. The first is called user-based. And in user-based, what it's doing is it's trying to answer the question, users like you also liked what? So as a simple example, consider Mr. Blue. Say the algorithm is trying to predict how much Mr. Blue would like Lord of the Rings. Mr. Blue hasn't rated Lord of the Rings in the past, so we just don't know the true answer, but we can estimate it. So what the algorithm will do is it will scan all the users and say, which of the users are most similar to Mr. Blue? Which 2 users are the most similar? And it might say, oh, Mr. Green and Mr. Red are the most similar because they've all watched Gladiator, they've all watched Saving Private Ryan, and so on. And so they'll use Mr. Green and Mr. Red's ratings to estimate what Mr. Blue will like, or how much Mr. Blue will like Lord of the Rings. So in this case, the algorithm might think, oh, Mr. Blue is going to rate Lord of the Rings a 3 because Mr. Red rated it a 3. And it's not exactly that. It's usually a weighted sum of some kind, but that's the major idea. The other kind of collaborative filtering is called item-based. And it's the exact same idea, except instead of trying to find similar users, it's trying to find similar items. And what the question it's answering is, buyers of this item also bought. So it's a little bit different than user-based. It's confusing at first, but they are different. So again, if we're trying to, if the algorithm was trying to predict how much Mr. Blue would like Lord of the Rings, what the algorithm will do is find movies that are similar to Lord of the Rings in terms of their ratings. So again, it'll compare every single movie with Lord of the Rings, and in this example, it might say, oh, The Matrix is very similar to Lord of the Rings. So then it'll say, okay, I know that people who rated people like The Matrix didn't like Lord of the Rings, so, and I know Mr. Blue liked The Matrix, so I'm going to predict that he didn't like Lord of the Rings, and so on. And again, the actual math under the hood is more complicated than that, but that's the main idea. Okay, so that's collaborative filtering. Content-based is different in that it's not going to use the utility matrix. Instead, it's going to use something else. Let's see how it works. In content-based, what the algorithm does is it first builds these item profiles. And this is usually the algorithm needs help from a human to do this, but this is just a pre-processing step. And basically, in this item profile, we write down everything we know about the items. So for example, in Netflix's domain in movies, what do we know about movies? We know their genre, what year they were made, who the director was, the stars of the movie, the length of the movie. You could even put in the rating. You could put in the, what else could you put in? Maybe some reviews from Rotten Tomatoes, things like that. So you write down everything you know. And then, for every single user in the system, you make a copy of this item profile, and you add one more column. The column is Mr. Blue's, or this individual user's, rating of the movies. So here we're showing Mr. Blue's copy of this matrix, and we see Mr. Blue has rated some of the movies, not all of them. But now we have a matrix of numbers, but we also, if you take a machine learning view of this, we have labeled training data. So we have predictor variables and a target label. And so what the content-based algorithm does is it inputs this matrix into any machine learning algorithm, and in any kind of classifier or regression. So nearest neighbor classifier, decision tree, naive Bayes, neural network, lots of different approaches. But the machine learning model will learn, based on the ratings, what this user likes and what this user doesn't like. So it might learn, oh, this user really likes comedies, and this user really likes movies around 2005 time frame. So it builds up this model, and then it keeps this model around for every single user, a different model for every single user. And then it'll use that model next time the user logs in to predict which unseen movies this user would like the most, and that's what it would recommend. The hardest challenge, the key challenge in content-based is creating those item profiles, which it's not an exact science, it's more of an art. And it depends heavily on the application domain. So for movies, like we just saw, we chose to write down genre, actors, directors, and so on. But if we were trying to instead to recommend news articles, then we would need to think about, well, how do you describe a news article? It could be the author, the source, the date, the topics of the article, maybe the keywords. But if you're trying to do a recommender system for televisions, what would you do there? You could do things like screen size, manufacturer, screen resolution, number of HDMI ports, things like that. So creating the item profile is the hardest part and the biggest drawback of this approach, is because it's such a difficult task to get correct. But once you do, it works very well. And finally, there's the knowledge-based class of algorithms. And again, this is where the user specifies exactly what they want, and then the algorithm just goes and finds all matches. So when do you want to use a knowledge-based? Basically, you need to use it when the products you're trying to recommend have a very low number of ratings. So think of a luxury mansion in Miami. This thing might have only been purchased once or twice in history, and there's not that many mansions that are comparable. So there's just no data to compare. There's no utility matrix. You can't compare it. There's not a lot of people that buy a lot of these things. Same with expensive sports cars that maybe only very few people own. Since there's no data to do any kind of automated recommender system, then you just have to use this knowledge-based. Another reason you might want to use knowledge-based is if your customer is very particular about what they want. So if you find your customers say, I want the car to be black, that's very important to me. Or they say, I want at least a 3-car garage, it has to be a 3-car garage. Then you're going to have to build a system that takes this into account, and that's a knowledge-based system. So here's a comparison of all the algorithms we just talked about. Collaborative filtering, content-based, knowledge-based. They all have pros and cons. In general, I'll kind of distill this table down for you. If your goal is to have the highest accuracy recommendations, then content-based is your choice, because it's built on just one person's history, and so the model is going to learn exactly what they like, and it's going to keep recommending things like that. However, the big downside here is it does give the user a bit of funnel vision, in that it might only recommend things similar to what they've watched in the past without expanding their horizons into new genres or new time periods or new directors. And sometimes that's what the user wants. The user wants recommendations for new things. Collaborative filtering is great to solve that latter problem. It is really, that algorithm is really good at finding new things that the user might want, and it might expand the horizons because it's using data from peers and people that are like you but not exactly like you. The biggest downside for collaborative filtering are individual recommendations might not be that accurate. Now, it's going to try some things out, but it might just miss. It may just have some bad recommendations. Also, collaborative filtering needs a lot of data to perform well. So you need lots of ratings from lots of users. Otherwise, the utility matrix is just too sparse, and the algorithms can't work very well. And then finally, knowledge-based. You basically only use this if you have to. If you're dealing with those products that just don't have enough ratings or transactions to give you the data you need to use the other two. Okay, so I know there's a whirlwind tour of the algorithms and how they work underneath the hood. Here's a couple of other considerations that you as a manager of a recommender system team or a designer of how it all works would have to take into account. First is context. So a lot of times, if you knew the context of a user, that could affect which recommendations you give them. For example, one context is their physical context. Where are they? What's their location? Or what time is it? So for example, if I was using my phone to look up restaurants, it would be great if the recommender system knew that I was in Kingston and that it's lunchtime. And that way, if it started giving me breakfast recommendations in San Francisco, those wouldn't be very useful to me. Another one is environmental. So weather, what's the weather outside? If it's a bright sunny day and it's recommending to me that I stay inside and play video games, that might not be ideal. Also, personal context. What is somebody's health or mood or even schedule? If you could take into account somebody's schedule and know if they have time to do what you're suggesting that they do, that would be ideal. Also social. If you know who was in the room, that could also help the recommendations. So for example, if I'm looking up restaurants and they knew that I was in a room alone with my wife, it might want to recommend romantic sit-down dinners. But if it knew I was with my soccer team, a bunch of rowdy guys, it might recommend that we go to a sports bar, something like that. Another consideration is shared accounts. So a lot of times people share online accounts. Netflix is a good example. And this actually turns out to be a problem, because if you share an account with your roommates or with your spouse or your family, then Netflix algorithms are going to be confused. It's going to have trouble learning exactly what you like, because you kind of have this split personality disorder. So this basically means that the recommendations it might give you could be dominated by one user if that one user watches the most TV, or maybe the recommendations are just too general. The algorithm is trying to find something in the middle of everybody, but they're not good for any individual user. So something to take into account. Another problem for recommender system is called a cold start problem. And this is when new users or new items are added to the system. In the new user problem, say you just joined Netflix and Netflix doesn't know anything about you. Well, it's obviously not going to be able to make good recommendations or good personalized recommendations. So what do you do in that case? In that case, you either try to get other data about that user, maybe from their browsing history, or you buy that data from a third party, or what you can do is just don't make personal recommendations for that user yet. Just use the generic ones, the top 10, the trending, that kind of thing. And then the new item problem is when you add for example, you add a new movie to Netflix. No one's watched it before, no one's rated it before, you have no data on it, so how can you recommend it? The solution here is to, instead of using a collaborative filtering-based approach, is to use a content-based approach. And that way you know, okay, this new movie, even though I don't have any ratings for it, I know it's a horror movie. And we have a lot of other horror movies on Netflix, so we can use that as a start. Another thing to take into account are attacks. So, you know, we talked about the billions of dollars that are going through these recommender systems every year. Well, now sellers of products and services on Amazon, for example, they have a huge incentive to manipulate the recommender system so that their products are ranked the highest, or that they're recommended the most often. So there's a lot of ways that users attack. Here's a few. But for example, there's something called a push attack, and that's where a user writes a bot to submit high ratings for all of their items. So say I sell shoes, I get a bunch of bots to rate my shoes really high. I could also do a nuke attack, where I get those same bots to rate all other shoes very, very low. And that way, when the recommender system is looking for, looking in the utility matrix and looking at the ratings, it'll see that my shoes are always rated the highest. There's a couple other attacks. The good news is there are some countermeasures in place, are being put in place at least. One is to increase the cost of ratings, or how hard it is to submit a rating. So these are things like CAPTCHAs. This is to hopefully deter bots from being able to work, or things like limiting the number of accounts for a single IP address. So if you notice 1,000 ratings from one IP address in any given day, you know something's going on. Another thing I didn't list here, but I just thought of, was on Amazon, now they have this verified buyer status, so that people can only rate the item if they've actually purchased the item. That's another way Amazon is attacking or countering all these attacks. There's also some research on automated attack detection. So there's algorithms trying to detect suspicious users. Basically, they're looking for users who have rated, for example, 1,000 shoes in one day. That's just kind of weird. It's probably not a real person. Okay, so let's put all that into context with a case study on Netflix. So the context for Netflix: Internet TV is a young space, a ripe space in terms of market, and competition is ripe. Netflix thinks that their recommender system is the key pillar of their product. In addition to the content itself, they think that the recommender system is their key to success. So what Netflix does is they don't use one recommender system algorithm, but they actually have a collection of different algorithms to serve different use cases, as we shall see. But here's a bit more motivation. So from Netflix's point of view, they think that Internet TV is about choice. They want to give people the choice of what to watch, when to watch it, and where to watch it. However, they have found that humans are really bad at choosing between a lot of options. So they have done some data analysis and found out that members lose interest after 60 to 90 seconds, and having reviewed at most 20 titles and only 3 in detail. So said another way, if one of their members hasn't found something to watch within 90 seconds, then they're going to leave and they're going to go somewhere else. So Netflix has talked to their users, and what their users say they want, or what they think they want, is as much choice as possible and an easy way to search and navigate all the titles. But Netflix disagrees. What they think customers actually need is just a couple of choices that are really good and presented simply. Netflix says, I don't need to show my user 1,000 things. I need to show them 3 things that they actually want to watch. And if you use Netflix, you might have been frustrated in the past to learn that there is simply no way to view all of the titles on Netflix. You might think this was a design flaw in the user interface, but in fact, this was a very intentional choice by Netflix. They don't want you to be bogged down with this choice overload, so they don't show you all possible titles. Instead, their recommender system is the only way to find movies to watch. So they say that about 80% of the watches come from their homepage recommendations and 20% from search. And again, so they think their recommender system needs to make sure that each member will find something compelling to view within 90 seconds, and the user will understand why they want to watch it. So the way they do it is they use a lot of different data sources. They use data such as what each member watches, obviously is a big one, but also how they watch it. Do they binge watch it all in a weekend? Do they watch it every night on like clockwork from 8:30 to 10? What do they do? Also, when do they watch it? Again, do they watch it weekends, nights, during the day? How long does it take them to finish watching it? When did they discover the video? How did they discover the video? Also, they know in the past which recommendations they've shown the user, but the user didn't click on. So they have lots of rich data sources. And they use all those to build 5 different recommender systems, each one using a different algorithm that we just talked about. So the personalized ranker, the top-end ranker, trending now, and so on. So here's the Netflix homepage. The way they have designed it, it's a matrix-like layout with rows and columns. Each row there is the output of one recommender system. And they typically have 40 rows, so they have 40 different recommender systems, or at least they run the recommender system 40 different times. So for example, in this screenshot, the first row is Netflix Originals. So this isn't a personalized recommender system. This is just the original Netflix shows. Down there at the bottom it says Top Picks for Shapri, which is the user's name. This is a personalized recommender system. This would be a based on what Shapri has watched in the past, and so on. So if you were to scroll down this page, you'd see different recommender systems for using different algorithms. Their search page, here's a screenshot of their search page. It also actually is a recommender system. So say you're searching for a title and you type in the letters G-O. Now there's thousands of titles with the movie G-O in it. So the Netflix has an opportunity here to show you just the G-Os that it wants you to watch, or the ones it thinks you will be most likely to watch. So it'll actually do a recommender system on the search results to order the search results in the best way. Also, Netflix actually, so when you click on a title in Netflix, it'll show you some more details, some metadata about the show. The interesting thing here is, for every title, Netflix has lots and lots and lots of metadata to show you, and it can't show you all of it. So it actually has a recommender system to recommend which metadata items you would be most interested in. So it knows whether you want to see what the stars' names are and what genre it's in and maybe a short summary, or if you want to see something else. What's going to make you like this show the most? There's actually a whole algorithm for that. Okay, so the business value of Netflix's recommender system, basically Netflix wants to conquer the world. It wants to grow business to an enormous scale. Its main goal is to prevent churn, so it wants to keep users engaged and active and happy. Netflix has a 100-person team for the recommender system, and they estimate that it makes or saves them $1 billion a year. And the chart there at the bottom, you can see that Netflix, in the US at least, has now overtaken cable subscription. In Netflix, there's a couple key open problems. One is that the global populations and language. So as Netflix is expanding to other countries, they're finding that their recommender system was recommending House of Cards to someone who lives in Thailand. But House of Cards is not available in Thailand, or in Thai, I'm sorry, in Thai, and there's no subtitles for Thai. So that's a problem. Another problem is the cold starting problem like we talked about earlier. So Their recommender system does a great job once it gets to know you, but before it doesn't have any data on you. So what Netflix does right now is they actually have a survey that it asks you some questions. You know, do you like this movie? Do you like that movie? It's basically filling in some of that utility matrix during the sign-up process. Netflix has the account sharing problem, like we talked about earlier. You know, they have a lot of people sharing the same account. Now, Netflix does have a feature where you can create separate accounts on one device. The problem is not everyone uses that feature, and so they still have to tackle this one way or another. And then finally, they found that children are a big problem for Netflix, for their algorithms. Because if anyone has kids, you know that kids like to watch the same thing over and over and over again. And the algorithms weren't set up for this. You know, typically adults only watch a movie once, or once in a while they'll watch it, but not 10 times in a row. Also, children's tastes change more rapidly. So the difference between a 3-year-old and a 6-year-old in what they want is huge. But an adult, you know, your tastes are pretty much locked in, and they'll remain true for 20, 30, 40 years. Okay, so here's a quick summary of the slides. So we're talking about recommender systems. And these are very sophisticated and useful systems to recommend items to users. And the main goals are to keep users happy, engaged, profits high. It's a very important AI system. There's a lot of approaches. We talked about 2 main approaches: generic, which aren't based on historical user data, and then personalized, which are based on user historical data. And within personalized, there's 3 different kinds, all with pros and cons. The state-of-the-art systems and tools are very effective, so any business that is not using a recommender system should. There's really no excuses at this point. And before I conclude and start taking questions, I'll just reiterate for anyone who joined late, the purpose of these slides was just to give you a flavor of some of the topics we cover in the programs, both MMA and MMAI. It's not a full, this is just a taste. It's not a full lecture, obviously, because normally I would spend 4 hours talking about this topic. We would do some examples by hand. We'd get a little bit more into the math of how the similarities are calculated and the recommendations are generated. And we might do an R or Python workshop in class, something like that. So most lectures have a bit of theory of how it works, a bit of business value on how to use it and why, and then a bit of technical practice. Okay, thank you guys all for your attention. Now I see some questions coming in, so I now will start taking questions. And if you think of any more, feel free to send them along, and I will get to them one by one. Okay, so first question is, can you use a combination of recommender systems? For example, we augment content base with collaborative filtering to provide extra insight. This is a great question, and in fact, yes, you can. And most companies are doing that now because it's a really good approach. So basically, you build not one recommender system, but a bunch, maybe 5 different kinds. You run all of them, and then you take the average or the top recommender or the item that was recommended the highest across all of them. And this has proven to work very well. You kind of get the best of all worlds for each recommender system. And where each recommender system fails, the other ones will succeed. So yeah, this is an excellent way to really get the best recommendations. Okay, another question. Have recommender systems been used to determine new products? As in, using the data that Netflix has, can they identify what types of shows will have the greatest chances of success, and then go out and make those? Ooh, another interesting question. Yes, I have seen this actually. Recommender systems, because they process the data in such a way to know who likes what and when and how much, if they take an aggregate view, they could identify gaps or trends. Say, look, people are really starting to like the comedy sci-fi genre, and it's popular in this demographic, and this is what our recommender systems are always recommending, and people are always clicking on it. So this is what we want to keep producing content on. So yes, and that's an interesting use case because it's not what recommender systems were originally built for, but it is a kind of a happy consequence that you can use them in that way. Very good question. Okay, another question. What kind of assessments would you give in the MMAI program based on this type of material? Yeah, good question. So in the MMAI, there'd be in-class, I'll call them assessments, but I wouldn't actually grade them, but in-class activities where I would give you a little problem right in the middle and say, for example, I'd give you a utility matrix, and I would say, calculate the most similar users to Mr. Blue. And so you'd use a similarity metric that I would teach you. I didn't in today's slides because we didn't have time. I took those out. But you'd do a little math and come up with top similar users, just to make sure you understood how it worked. Those kind of activities. There maybe be 3 to 5 of those activities in class. In terms of assignments and projects, so there would be some teams would get a whole course project on using a recommender system on a real-world data set. So we have a lot of partners in industry who give us real-world data sets, and these could be bank transactions, these could be logs of trucks driving around the country, these could be loans, and lots of different kinds of data sets. And each team is assigned one of these data sets and a task, like build a recommender system, or build a neural network, or build this. And so basically you come up with the business case, you do the data pre-processing, you build a system like this, it would generate recommendations, and then you would say, how would you use this in a business context? And then you would present it to both the instructor, me in this case, and maybe some industry professionals to do a guest judge. Okay, next question. How would you go about building a recommender system that recommends which type of recommender system to use? I like where you're going with this. Yeah, basically skip the whole 4-hour slides and just have a recommender system tell you what to do. Yeah, that's a good question. Probably with the knowledge-based, because probably a business would say, they'd want to say, I want a recommender system that A, runs really quickly, or B, has the most accuracy, or C, can work without a utility matrix because I don't have it. Basically, the company would have these strict requirements, and they would need to input those, and then the knowledge base could then say, okay, in that case, your best option is, X recommender system. Well, that's an interesting question. I like it. It's a meta recursive question. Okay, next question. Do you cover this material in depth in MMA as well? Yes, actually. This is one of the reasons I chose this topic, because it is covered in exactly the same depth in the MMA and the MMAI. In fact, with our redesign of the MMA curriculum, we have a course called Machine Learning and AI. It's in fact the same course in the MMAI. So the MMA and MMAI, they share 7 courses. One of the courses is called Machine Learning, and one of the lectures in that course is this. So I do apologize. If any of you guys do take the program, then you will hear me give these same slides again, except in more detail. It'll be a 4-hour version instead of a 30-minute version. But big picture, yes, you would get this in both programs. Okay, last question. How much data is typically needed to get a reliable recommendation? That's a great question. So for collaborative filtering, you need the main data source is the utility matrix. There's no one answer. I can't say 10. You need 10 data points or anything like that. There's no single minimum. Obviously, more is always better. In general, you need tens of ratings per user at least, and hopefully hundreds or thousands of ratings per item in order to get reliable recommendations. If you don't have that, then there have been some mathematical techniques proposed, such as clustering items or clustering users, or maybe some latent factor analysis, or some way to compress the matrix, basically, that can be used until you get enough data. And that seems to work okay. For content-based, when you're building a model for each user, yeah, again, there you need, it's hard to put an exact number, but at least 10 or so, but ideally dozens of data points for each user, because otherwise the machine learning model is just going to be learning noise. For example, in the extreme case, say I've only rated one movie, and this movie happened to be made in 2006, and it happened to be a chick flick, and it happened to star Tom Hanks. Well, the machine learning model, given that's all it knows about me, so that's what it thinks I like, and it thinks I like nothing else. So you need to give it enough data for it to have a realistic view. So again, there's no exact minimum, but a dozen or so, any less than that, and the model's just learning noise. Oh, one last question. Last one just came in. Are recommender systems usually B2C? What examples are there for B2B recommender systems? Yeah, so no, they don't have to be B2C. Mostly they are, but certainly, let me think if I can think of an example for B2B. So if you can, this can be generic, not a crystal clear example, but if you had a B2B website that sells a lot of products, like let's say a dentist supply store, that's B2B, but and that system could have a recommender system as well. I don't know if that really gets at your question, but really B2B isn't the important part. The important part is if there are too many items that the user can't scroll through all of them one by one, if that would just take too much time, then a recommender system can be used and probably should be used. Okay, well, thanks everyone again. This video will be posted on the website and some point in the future. In the meantime, if you have any questions about this topic or about either program at all, feel free to contact us, Smith, or me personally. I'd be happy to talk to each and every one of you. And I hope you all have a good rest of your day. Thanks.